Hello and welcome to Physics Teacher. Now I find graphing inverse functions a lot of fun in grade 11 math, but let's make sure we understand what they are, how to find them, and then how to graph them. Let's get started. So we've learned about what a function is. Let's take this function right here. Let's do a simple linear one like 3x minus 2. Now if we input a certain value into the function, let's say 2, we get a single output. In this case, it would be 3 times 2, which is 6, minus 2, which is 4. So that's an output. But what if I wanted to figure out what the original input was given an output? So, for example, what if I told you the output was 4, and I wanted you to tell me what the input was? To do that, we're going to need an inverse function. So if you had a graph and you were to just plot a simple point on the graph, let's plot 1 and 3. So this is the point 1 and 3. So inputting 1 into your function gets you 3. So if I gave you the output 3 and I wanted the input, that would give you 1. So the point of this inverse would be the exact opposite. We just flip x and y. So that would be 3 and 1. So this point, 3 and 1, is the inverse of our original point. Now we can do the same thing to be able to find the inverse function. So let's look at our original function. I'm going to write this as y. So y equals 3x minus 2. And then I'm going to swap the x and the y. So I'm going to write y as x, and then I'm going to write x as y. Now what I want to do is rearrange to solve for y. So let's add 2 to both sides. So we have x plus 2 equals 3y. And then we can divide both sides by 3 to isolate for y. So that gives us y equals x plus 2 over 3. So this is our inverse function, and we write it as f negative 1 of x equals x plus 2 over 3. Now watch, because this is really cool. Let's go back to our original example here. We're going to take our output of 4, and we are going to figure out what the inverse function of 4 is. If we do that, we get 4 plus 2, which is 6. And 6 divided by 3 is 2. Isn't that amazing? We got back the input of the original function. That is an inverse function, and it's so cool. And you can show this working every time. Let's try a little table of values here. So we'll start with x, and we'll do our original function of 3x minus 2. So if I put in a 0, you get minus 2. If I put in x as 1, we get 3 minus 2, which is 1. And we already know that if I put in a 2, it spits out a 4. And if I put in a 3, we get 9 minus 2, which is 7. And we can watch the power of our inverse function. If we took, say, a certain value, and we figured out what its inverse would spit out. So let's take that negative 2, which is the output of our original one. Negative 2, if we put that into our inverse function, negative 2 plus 2 is 0. 0 divided by 3 is 0. Amazing. Let's try it with the 1. If we put 1 in, 1 plus 2 is 3, divided by 3 is 1. We already know that if we were to take 4 and put that in, we get a 2. And if we put in 7, well, 7 plus 2 is 9, divided by 3 is 3. See how amazing these are? Now, I have a trick question for you. Not a trick question, a challenge question for you. Are all the inverses of functions themselves? Let's think about that. I'm going to draw one of these mapping diagrams with my horrible ovals. Apologies. But let's say we take an example. So here are x's and our y's, and I'll just do 1, 2, 1, 0, 1, 2, 3, 4. And let's say I have different values. I don't know, 5, 7, 21, 43. I don't know what this function is. But if I plug in x and I get one value of y, that's a function. It's also okay if I were to plug in another value of x and get the same value of y, as long as one value of x doesn't give us two outputs. It's a function. But what happens if we find the inverse in this case? If we were to find the inverse, all we do is draw those arrows backwards, essentially. So 5 is going to give us both 1 and 3, meaning it's giving us two outputs. So this is not a function. So not all inverses of functions are functions themselves. Let me show you a great example on a graph. So take something simple like our quadratic. Let's just use the parent function of y equals x squared. We all know what that looks like. But what is its inverse function? Well, if you replace x with y and take the square root, you get y equals the square plus or minus the square root of x. So we get plus the square root of x, and we get y equals minus the square root of x. So look at our inverse function. The blue is our inverse. It is definitely not a function. It does not pass that vertical line test. But how did we get that graphically? I want you to look at the line y equals x. Let me make this a nice dotted line here. If you were to take your function and take a reflection of it about the diagonal line y equals x, that is what gives you your inverse function. So your inverse function is a reflection about y equals x. It's hard to see, but what I'd recommend doing is maybe printing this out or drawing it yourself on a piece of paper and folding that piece of paper along that diagonal line. And you'll see they fold right on top of each other. It's a great way to visualize it. Give it a try. Alright, so that's it for that tutorial. If you have any questions, let me know in the comments. And if you're going to be taking grade 12 physics next year, for a limited time, I'm offering my full course pack that you can download for free. The link is in the description. Thanks for watching.